All right, welcome back, students. In this video, we're going to cover Station 1 of the Geometry EOC BootCamp. This is Trig and special right triangles. So if you were at BootCamp, you would have seen me there. It was really cool seeing some of you guys that have been watching, and I had no idea. I hope and pray you guys do well on the test, and again, I can't thank you enough. Since I know you guys do listen, and for those of y'all that I met and hopefully are watching this because we talked, even though we just met, this is my last year at First Coast. So do me a favor, before the end of the year, come by. I'm in I-103 and sign my yearbook because just like to get to know you guys, and hopefully you can tell me you passed, and that's great. I'm proud of all you guys either way. I appreciate you taking the time to listen to me. So, that being said, Station 1, Trig and special right triangles. So, this section I made without diagrams, without notes. We're going straight into it. The booklet does have notes, but we're not going to use them. If you were at boot camp, this is the same way we did this. So, we're going to be working off. So, this is our EOC, the reference sheet. So our first two examples are going to come from here, and I'm going to draw these on number 1 and 2. But I'm going to talk about them for a moment, and then we're going to finish on the other side of this page, which is the trigonometry, the trigonometric, ratios. All right, so special right triangles. So if it's a 45, 45, 90, that means these guys are both 45. That means they're equal. If you're in geometry and you've watched any of my videos, I hope you know that equal also means they're congruent. So this is actually a right isosceles. Right isosceles. So these two are congruent. That X, that just means these two are congruent. So if this guy's 5, this guy's 5. If this guy's 8, this guy's 8. This is telling us that the hypotenuse is this value times the square root of 2. Square root of 2 is like 1.41. If the question asks for radical form, you would leave it like this. If not, and these don't, so we're going to put it in real form, and we're going to talk about the buttons we're going to hit on the calculator. The other one, 30, 60, 90. So this is a little more important as far as how it looks. We're going to model it after this on our, sorry, I got some green dye from Easter, believe it or not. It's still in my freezer, I think. Every time I make ice cubes, there ends up one green ice cube, and then I end up with green on me. It's a mystery. So more to come on that. So because these are the same and these are the same, this guy can be turned, and you're only going to make a mistake if you forget where the hypotenuse is. So this is a little different. So where you see the 90 and the 60, this is X. This is the smallest side. The side with 30 is X times the square root of 3. So it's the middle. It's bigger than this. Square root of 3 is like 1.73. Well, and the hypotenuse, so always across from the 90-degree angle. So if it has the box, draw an arrow. If not, just run your finger, and you'll run into the hypotenuse every single time. And this one's 2x, so it means the hypotenuse is double what this one is. So if this guy is 20, this would be half of 20, which is 10. If they gave you this side and told you it was 15, well, this is 15 times 2, which is 30. This guy over here is this value times the square root of 3. Square root of 3 is 1.73. So this will be in the middle. It'll almost be as big as this, but definitely more than that. So, like I said, this is the front of the reference sheet. So, let's do this part. All right, number 1. So, all these are right triangles. I had this made up without diagrams because we can draw the triangle our own way. I can show you everything the same way, and it kind of makes it a little more, it's easier for me to teach, and it's easier for you guys to kind of pick up the pattern. So we have a 45, 45, 90. So we're only going to write 45 for one of these because we know they're the same. Speaking of the same, so these two are the same. And this guy is x times the square root of 2. That's what we talked about on the other page. So take to my red pen. So it tells us that the hypotenuse, so across from the 90-degree angle, is 14. So I'm going to put this in red and circle it. What's the length of each leg? So the legs are these guys. It's a right triangle. You have the hypotenuse, and each of these guys are called legs. So if this value is this guy times the square root of 2, to go backwards, we're going to do the opposite, or the inverse. So the opposite of multiplying is dividing. So it's 14 divided by the square root of 2. Now, if we were doing this on paper, and we are, but I'm going to make this easy. As a math teacher, though, we want this guy out of the denominator, so you would multiply it by square root 2 over square root 2. So to get it to this times this is 2. Anything under the square root, if it's the same number, the answer is that number. Square root 2 times square root 2 is 2. Square root 3 times square root 3 would be 3. So you end up with 14 times square root 2 over 2. These cancel. It's 7 times square root of 2. Either way, these two, we're going to go with this. So in the calculator, calculator, and I'm not going to write calculator each time. I'm just going to, this one time, and it's going to be in the blue pen. So 14 divided by, now let me pull this calculator out. All right, so we see sine, cosine, and tangent. We're going to need those for trig. See above these, the green, that's sine to the negative first power, cosine, tangent. That's with the green button. We're going to use the inverse of those if we're looking for an angle measure, like maybe down here. If we're not, we won't use the green button. But I'm going to tell you step by step on the calculator. So we want 14 divided by, so we're going to hit the number first. Hold on. Clearly I didn't hit. So 14 divided by. So just below tangent, this button is for square root. This is to square something. So we need the number first. So 14 divided by 2, that is going to be in that. So 1.41, I said that earlier, that's the square root of 2. Now we got to hit equals. So our answer is 9.89. So 9.89 or 9.9 units, because we're rounding it up. But it was 14 divided by, so we hit 2 first, and then the button, this guy. So this button, and then equals. So 14 divided by 2 square root equals, let's see, we got 9.89 or 9.9 units. All right, so number 2. So this is a 30, 60, 90. We're going to make it just like it was written on the reference sheet. So you guys look there, or you can trust me. So it says the hypotenuse, so 2x is going to be 10. What is the length of the side opposite the 60-degree angle? So 60 degree is on the right side. The opposite of the right is over here, the left. So they want to know what this side is. Well, first, because this side is this times the square root of 3, let's just see what this is. So the hypotenuse is double what that guy is. So hypotenuse is 10. So 10 divided by 2. So 10 divided by 2 is 5. So this guy is 5. So now we know this is 5. This is 5 times the square root of 2, or 5 times the square root of, 3. I keep saying 2. Square root of 3. 5 times the square root of 3, because it's x square root of 3. So calculator in this color, I'm not going to write calculator again, but it's 5 times. This time it's 3, because it's the square root of 3, and then you're going to hit that square root button, and then equals. So 5 times 3, square root button. So square root of 3 is 1.73. Pretty sure I said that earlier. So 8.66, we're going to round that up to 8.7. this in a second. Okay, so now we're going to talk about trig. Flip over and go right here. So this is the opposite side of the reference sheet. So trigonometric ratios. So SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These all say this symbol here means theta. It's just the angle we're talking about. When we have questions that ask us for the angle measure, and you'll see those in number 3 and 4, we're going to use the second button because that's inverse sine to give it the angle measure. If we want a side, it's not the green button. We're just going to use, it'll be the sine, and they'll give us the angle, and then we'll be trying to find one of these two. All right, so SOHCAHTOA. During boot camp, I've had the little triangle, so we'll do it like this. So you guys, so on the side here, I'm going to write SOHCAHTOA. So sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you're either talking adjacent, you're talking opposite, or you're talking hypotenuse. So there's these three. These problems all mention 2. So whatever one that's not mentioned is the one we can cross out, and we'll look here to see. So let's just get started. It's number 3. So we're going to make all of our theta is going to be this side. So this is the right. The opposite of the right is the left. So when it says it's 9 units for the opposite, the 9 is going to be over here. That's the opposite of our angle. And the hypotenuse is always directly across from the 90-degree angle. So the hypotenuse is 15, so we're making this 15. The third side, so it's the side, it's adjacent, and it's not mentioned here. I'm drawing it, I'm going to show you there. So it touches our angle, but it's not the hypotenuse. If you remember opposite and hypotenuse, just remember this is the other guy. So they didn't mention adjacent. So that's an A. So this has an A, and this has an A. So I have to use sine. So we're using the inverse sine. Because remember I said if we are asking for the angle measure, we have to use the green button, and the green button means we're using the inverse sine. So inverse sine is opposite over hypotenuse because it's so. So it's going to be opposite's 9, hypotenuse is 15. So I'm going to write equals there. I know that I'm writing all this. So this is going to be your calculator. So for this, it's going to be 9 divided by 15, and you're going to hit equals. So let's just do that. 9 divided by 15 equals. So this 0.6, that's the sine for that angle. Now, we want to hit the green button, so that's the second key. And then we're talking about sine, so we're going to hit sine. So 36.86, we're going to round it up to 36.9 degrees. That's what our angle is. And we know that because of the calculator, but it was second sine. When you hit the green button, you don't have an equals at the end like you did here. When you don't use the green button, and then we won't for the length here and here, you'll see. So this one here, all right, so we have an adjacent and we have an opposite. An adjacent and an opposite, so it's tan, but if you look here, so they didn't mention hypotenuse. Both of these have hypotenuse, so you would have to use tangent. So draw our right triangle. We're over here. The opposite is 11. The adjacent, so that's on the bottom, is 7. Tangent equals opposite over adjacent, so that's 11 divided by 7. So in the calculator, and I was going to have you guys do this and tell you to pause it. I apologize. We'll do that. So here we'll do 5, but I'll pause it before 6 so you guys can work that. So 11 divided by 7 equals 11 divided by 7 equals. So that's the tangent. Now we're going to hit green button. Second. and then tan because we're using tangent. And if you mess up, so let me just bring this up. So if we hit equals, you see that's 57.5. See, it hadn't changed. Hitting the equals button again is not going to hurt you. If it starts changing the number, then just hit clear and go back. Oh, whoops. See what happens? 57.5 degrees. All right. Let me pause here just a moment. Okay, my apologies. Had to put my children to bed. So, all right, so number 5 and 6. So we're talking about the length of a side, not the angle measure. So no green button, so no equals. You'll see what I mean. All right, so we got a right triangle. And this time we have an angle measure. So we're not looking for the angle, we're looking for the side. We're looking for the hypotenuse. All right, so right triangle. So instead of theta here, we're going to write 42 degrees because that's what it told us. So this opposite side, so if we're on the right, the opposite's over here. So this guy's 12. And what's the length of the hypotenuse? Well, you know, math teachers, if we don't know what it is, we say it's our x. So we're looking for x. Nobody knows why. All right, so we have an opposite, we have a hypotenuse. So who got left out? The adjacent. So scooching up. So these two that have a, that's cosine and tangent, we can't use those. So we have to use sine. Or if you notice, opposite over hypotenuse, or opposite and hypotenuse mean sine. So sine equals the opposite over the hypotenuse. So it's always this, the things that change. So up here, we just wrote sine. Now we know what the angle is. So it's sine 42, and it equals the opposite, which is 12, over the hypotenuse, which is x. So I'm going to show you how we are going to rearrange this to get x. But let me tell you, so side note over here, so if x is on the bottom, then you're going to divide. If x is on the top of your fraction, you're going to multiply. I know you're like, x, well, just watch. So it's in the bottom here, so we're going to divide. I'll save that for my, so once I have it written, I'll show you in the blue pen. So x by itself, it's in the denominator. So I'm telling you it's going to divide. We're dividing this by this. So the first thing we have to do is get x out of that denominator. So we multiply both sides by x. So this cancels. So now we have x times sine 42. And the only thing left over there was 12. All right, so now we're going to divide both sides by sine 42. See, I said divide. So we're left with x equals 12 divided by sine 42. I'm going to put x equals here and leave a box. So now, how this looks in the calculator. So just like up above when we wrote square root 2, we had to do the number first, and square root 3, we had to do the number first. We're going to do the number first here too. So it's going to be 12 divided by, so 12, divided by 42, because I said number first, so 42. Now, I'm not going to hit enter. Don't do it, because if you do it, they're going to give you the result of this. That's not what we want. So we're going to hit, so not the second, because remember I said green button, or no green button. So 42, and it was sine, right? Yes, sine. So sine, all right, let me write that down. Hold on. So sine, I'll write it down here. Sine, so 12 divided by 42, sine, oh, it's 0.669. No. That, so the decimal or the fraction is your sine, cosine, or tangent. So we got to hit equals, because we want the length of a side. A length of a side is not going to be a fraction. So hit enter, And I said, no green button, you hit enter. Or not enter, but equals. 17.9, so our hypotenuse, our x is 17.9 units, because that's what all these are. But we had to hit equals. So again, just like it says, 12 divided by 42 sine equals. So 12 divided by 42 sine equals 17.9, 17.9. So I'm going to start you out over here. I would say pause, because these two are very similar to this. And I told you already, so if the x is in the bottom when you set up your equation, then you're going to divide, and if x is in the numerator, you're going to multiply. So we got a right triangle. There we go. So the angle's 35. It says the adjacent side's 18. Remember, adjacent's on the bottom because it's touching our angle, but it's not the hypotenuse. See, hypotenuse is always across from that 90-degree angle. What is the length of the side opposite? So over here, again, we call it x because why not? So we have an opposite and we have an adjacent. So who got left out? The hypotenuse. Hypotenuse. So notice these two both have the hypotenuse, so we're going to have to use tangent. So that's the two questions I got the most. How do you choose? And it's just whoever's not talked about, because it's 2 out of 3. Or I see opposite, I see adjacent. This is opposite hypotenuse, not that one. This is adjacent hypotenuse, definitely not that one. Opposite, adjacent. Opposite, adjacent. So it's got to be tangent. So tan equals opposite over adjacent. Well, so I'll get it set up. You pause. So our tan, we know the angle is 35 degrees. The opposite is x. The adjacent is 18. So again, when it's on the bottom, you divide like we did here. Whoops. If it's on the top, like it is here, you're going to multiply. This is how. So let me show you this. So you multiply both sides by 18 because we want x by itself. We got to get rid of the fraction. These two cancel. I'm just writing this backwards now. So x equals 18 times tan 35. So hopefully if you're paying attention on the calculator, you know you're going to put the number first. So it's going to be 18 times 35. Do not hit equals because 18 times 35 is a big old number and we're only looking for the opposite side. So we're going to hit tan. That is the tangent of that. Well, yeah, that's the tangent of a 35-degree angle is 0.7. So now we have to hit equal. Let me write that in though. Tan first, or tan after the number, and then equals. And so we get 12.6. The 12.6 units. Oops, didn't realize I was off the page. So the adjacent side's 18. That's the medium side. This is the small side, so it's smaller than 18. So that makes sense. So let's set up at the bottom here. So again, these will go for this. This is a little different. They're both right triangles. We're going to change, though. This thing is saying sine of A, cosine of B. Well, we're going to make this A just like we've made everything. And I'm going to show you with, actually, I'm going to show you like this. This is something, little bonus material you guys didn't see at the boot camp. So this is like behind the scenes, or what is it, like a end credit scene or something. I don't know. I'm being silly, but I'm trying to be funny. So hopefully you guys get what I'm saying. Sorry, a little parched. So we'll come back to that. So over here, right triangle. There he is. Angle measures 61. There that is. The hypotenuse is 20. What's the length of the adjacent side? So down here. So that's X. So, number one, who is missing? That'll tell you which sine, cosine, or tangent you're going to use. And then you can decide where X is, and that'll tell you if you're going to divide or if you're going to multiply. So pause the video here. See, there's that die again. Or I couldn't even tell. I told my wife a minute ago. I was like, I got more die. It's in the freezer. I'm doing the video. And anyway, sorry. You guys don't need to hear about my problems here at home. But yeah, so, you know, tomorrow's May 1st, and we have Easter egg die still lurking somewhere within this house. So anyway, so hopefully you paused. If you haven't, pause now. I'm going to wait 5 seconds. I'm going to count out loud, and then we're going to work the problem. So for my folks that are really trying, this is where you try. If you're just taking the notes, then don't pause. Keep going. Here comes the notes. So 1, 2. Oh yeah, this is a chance. So I was going to do some of my impressions, and I was afraid it would cause too much disruption, and I'd get in trouble by Miss Walton during the boot camp. But so I have a Muppet shirt that has 9 characters on it. Of the 9, I can do 6 voices. One of those, I'm going to try to wear it next week. If you come up to me, I'll do some of the voices for you. I usually don't do them on command. It's got to be a mood thing, but I love you guys, and if you take the time to ask me, I'm going to do it. So one of them is Animal. So if you know the Muppets and you know Animal, they've got that new roller coaster that used to be the Aerosmith rock and roller coaster. Now it's going to be featuring the Muppets with the Electric Mayhem, which Animal's the drummer. And if you find the video, now actually I'm trying to think if I made this up in my head. I've seen the video because they show him the songs and he says, "Carried." Well, that wasn't very good. But what I've started doing is, "Coaster, coaster, coaster." So hopefully you like that. I mean, I don't do well on the spot, but we tried. All right, now to our problem. So we had a hypotenuse and adjacent. So that left out opposite, this guy. Well, if you look, opposite goes with sine and tangent, so we have to use cosine. So cosine equals the adjacent over the hypotenuse. So in our case, cosine 61 equals the adjacent, which is x, over the hypotenuse, which is 20. So x is on top. X is on top, then we're going to multiply. Let me show you how. So 20 is on the bottom of this fraction. We multiply. Sorry, got an email. We multiply both sides by 20. This cancels this guy, so I'm going to write this backwards. So x equals 20 times cosine 61. So I just write x equals over here. Sorry, I went over there, but it's fine. So on the calculator, 20 times, so 20 times 61, because I got to get the number first, then cosine. See, that is the cosine for a 61-degree angle. And shout out to whoever, and really, if you hear this on the video and you did tell me this, and I'll know who you are. I remember faces, just I don't know names. But somebody this week during boot camp said, well, this is 61 degrees. If the hypotenuse is 20, then this should be 10. That's half of it, because in the special right triangle, this would be 60. Well, it's 61. That's close enough. Shout out, because that was smart, because I didn't even think like that. I don't think outside the box, and anybody that thinks outside the box, major props. So it's not 10 because it's not 60 degrees, it's 61, but it's pretty daggum close. So when you hit the equals button, so you get 9.69, we round that to 9.7, which is pretty dang close to 10. So again, come see me. All right, finishing up. Number 8. This one's completely different. So it's asking for the sine of A and the cosine of B. We're going to give it the sine of A and the cosine of A because the sine of A is going to be the same as the cosine of B. Because, so if this angle's on the right, the opposite of this would be, opposite of right is left. Well, this is at the top. The opposite of the top is the bottom. Your adjacent and your top swap, your adjacent and your opposite swap. Hypotenuse is always the same. So that you would see they're the same. I don't need you to see that. I just told you. So we're going to do sine for A, cosine for A. So it tells us that the legs are A equals 3, B equals 4. A is opposite of A. So over here, A is 3. So that makes this guy 4. They don't give us a hypotenuse, do they? So if you were at boot camp, you already know how to do this. But if you weren't, how else do we find another side of the triangle without using trig or special right triangle? Hopefully you already know because they talk about it. Side A, side B. So A squared plus B squared equals C squared, Pythagorean theorem. So for here, it's 3 squared plus 4 squared equals our C squared. So in the calculator, so again, this is the square button. This is the square root. So you would go 3 squared, that's 9, plus 4 squared, that's 16, equals 25. So C squared equals 25. So we're going to hit this button, and you'll see that C equals 5. So our hypotenuse, excuse me, is 5. Sorry, had a hard time with the tickle in the last class today. So sine, that's opposite over hypotenuse. Cosine is adjacent over hypotenuse. Oops. Okay. So opposite is 3. Hypotenuse is 5. Adjacent is 4. Hypotenuse is 5. Well, 3 divided by 5 is 0.6. 4 divided by 5 is 0.8. So a lot of folks are like, well, why is it a fraction or a decimal? Because they ask for the sine and the cosine. That is a fraction or a decimal. Everything else asks for a side or it asks for an angle. So that's why it's different. So, if you have any questions, let me know. If you like the video, please like it. And if you're not a subscriber, go ahead and subscribe. I know we're almost done with the year. I'm going to post the rest of the stations from boot camp. Our test is just less than a week away. Thank you guys for all your hard work. And again, thanks for letting me know you've been watching it. It made my day. And I can't thank you guys enough. So, see you soon. Have a good night.